Hello. I wanted to talk today about some polynomial applications, and in particular using formulas. Now there are many ways to talk about formulas. A couple of them that are prominent are evaluating formulas or solving for a particular variable. And so for this video, I would like to focus on just this guy, evaluating formulas, and in a different video we'll talk about solving for variables. But in evaluating, it means we start with a formula and then we're given a value or values. We plug the numbers into the formula and then see what we get as an output. So for example, here's a pretty popular formula. Let's say h equals 1/2 gt squared plus v naught t plus h naught, or v0 or h0, some people call it. What this is the height of a falling object given a certain time and a velocity and an initial height and the acceleration due to gravity here close to the surface of the Earth, on the surface of the Earth. So the gravity on the surface of the Earth is pretty well defined and pretty consistent. It's 9.8 meters per second squared, or 32 feet per second squared, roughly. So suppose we stuck in a g of 32 feet per second squared, okay, and we're given an initial velocity of, oh, I don't know, 5 feet per second, and an initial height of 6 feet. Okay. Well, I could plug all that information into the formula, and I couldn't quite compute it yet unless I was also given a time. So let's go ahead and stick, how long is this thing? Let's just do time equals, well, just do 1 second to keep it simple. Okay, time equals 1 second. So given all this information, how do I use this formula for the height of the object? Well, I just plug the numbers in, and be careful. Let me do that and see what happens. H equals 1/2 times the g, which is 32. And you're going to have to trust me on this one that all the units are correct. The feet per second squared, feet per second, feet, seconds, so on and so forth. They are correct and consistent with the formula. Times t squared. So I'm going to put times 1 squared plus 5 times 1 for the v naught t plus 6 for the h naught. And then be very careful in cranking the machine and see how this comes out. Really, it's just following the order of operations, and we are now evaluating this formula given all this information. So that would come out to, I'm going to do 1/2 times 32 here to give me 16. 1 squared is just 1, so I have a times 1 right there. Plus 5 times 1 is 5, plus 6 equals 16, plus 11, I just added those guys together, equals 27 feet. The height is going to have to come out in feet. So for an object that started 6 feet high, and then it was given a kick of 5 feet per second, for 1 second, after that time, it is exactly 27 feet high. And we have used and evaluated this formula. Let me give you another example that's pretty popular. Let's use a different color just for fun. How about C is equal to 5/9 times F minus 32. This is a squeaker pen. This is the formula that gives you a Celsius temperature given a Fahrenheit temperature. So if I want to evaluate this formula, I can say, well, how about F is equal to, how about boiling? 212 degrees. That's at standard temperature and pressure. So if that's true, I'm going to plug this guy in here, and that means that C is equal to 5/9 times 212 minus 32. And now I just be careful to use the order of operations to evaluate the rest of this formula. 212 minus 32 is in the parentheses, so I'm going to go ahead and do that first. This gives me 5/9 times 180. I'm going to do a little reducing here. You should probably review this if it looks confusing. Fractions times whole numbers. Let's just reduce both of these by 9. So this becomes a 1, this becomes a 20. 5 times 20 is 100 over 1 is just 100, so this comes out to 100 degrees Celsius. And there we go. We have evaluated the formula. And that's really all evaluating is. Let me do one or two more formulas before I end this video. Of course, you could stop it if you feel like you've got the idea, or if you want to see more formulas, hang on. It does take a moment to erase this contraption. Doo-doo-doo. Someday my face will appear through the muck. Oh, here it comes. Doo-doo-doo-doo-doo-doo. Sometimes you got to put a little elbow grease on this, and my elbows aren't very greasy, so that gets a little difficult for me. Maybe I'll get on Amazon and order some of that greasy elbow stuff. Okay, where are we at? Let's do another formula. How about blue? Haven't used that for a formula yet. I got a couple of formulas written down. Oh yeah, I wanted to point out this one. How about volume? Equal to 4/3 pi r cubed. 4/3 pi r cubed. This is the volume of a sphere. It tells you how much stuff is in a sphere. Literally, it tells you how many unit cubes are in a sphere, which is kind of a weird thing to think about. But suppose we were given a radius. That's what the r is. That's all we need to know to compute the volume of a sphere. Let me just draw our little sphere real quick. Something like this. Trying to draw a little three-dimensional sphere. It's not that good, but something like that. And starting out from the center and going to some edge, that's the radius I'm talking about. So, I don't know, let's say we have a radius of 2 inches, a radius of 2 inches. So we're given r equals 2 inches. Then, to evaluate the formula, v is equal to 4/3 times pi times 2 cubed. Now you just have to be careful with this fraction, multiplying all this stuff here. I'm going to go ahead and cube this 2 and say that I've got 4/3 pi times 8. 2 cubed is 8. I don't really see any possible reduction. This 4/3 times the 8. I don't see anything happy there. So I'm just going to put all these guys together in the numerator. 4 times 8 is 32. There's my pi, so 32 times pi all over 3. Why am I allowed to do that? Well, you could always just put a 1 under this, a 1 under that, multiply straight across the top and the bottom, and that works out. Also, this would be the same thing as 32/3 pi. These are all the same thing. Now, if I'm writing a final answer, you may or may not have to turn this into a mixed number. You may or may not have to multiply by the approximate value of pi. But one thing I do need to do is put inches cubed here, put my unit. Because I started out with a radius of inches, I cubed it, so I get inches cubed. And there is what we would call an exact answer. Exact answer when we evaluate a formula. It's called exact because here pi is just represented by a symbol, and so it is preserved as a perfect number. It's an exact number. If I use some sort of approximation like 3.14, 3.1459, take it as many places as you want, then you're truncating or rounding, you're taking some of those decimals off, you're shaving them off, and you're therefore approximating. Now, in the end, when you're engineering something, the approximation probably has to come into play eventually, and you would multiply these two quantities to get your final result in inches cubed, rounded to whatever specification you were looking for. So there's volume. I think I'll stop with evaluating formulas. I could do more formulas. There are more formulas than I know, of course, and than you know, but that's the essence of evaluating a formula.